Take a look at this real-world example of a chart that shows gun death in Florida over several years. You might notice the decreasing trend after 2005 when Florida enacted its Stand Your Ground law. But you might also notice that the y-axis is completely flipped. So we need to flip the entire chart in order to read it. Now 0 is on the bottom, and it's clear that the trend is actually increasing after 2005. When charts are sending misleading messages, this is something called visualization misinformation, and there are many more real-world examples like this. The question we are interested in is how well can the general public identify visualization misinformation? But before we can answer that question, we need to first have a way to assess this ability, which we define to be the ability to read, interpret, and reason about erroneous or potentially misleading visualizations. This ability would require more than merely reading information off of a chart. It needs critical thinking skills during visualization interpretation. We contribute CALVI, a critical thinking assessment for literacy in visualizations. CALVI has a bank of 45 items designed to measure people's ability to identify visualization misinformation. Shown here is an example item from the bank, which asks people to answer multiple choice questions given a visualization. After going through a systematic process of test development, including phases such as test conceptualization and construction, test tryout, and test revision, we finalize a reliable bank of 45 items in CALVI. During test construction, we looked into literature for ways a chart can mislead and reviewed categorizations by McNutt et al. And by Lowe et al. To compile a set of what we refer to as misleaders, and define them to be decisions made in the construction of visualizations that can lead to conclusions not supported by the data, such as inverting the y-axis, which falls into the manipulation of scales, unconventional scale directions category. From a previous visualization literacy assessment test, VLAT, by Lee et al., we used a set of chart types that more commonly appear in reality. With a combination of 11 misleaders and 9 chart types, we constructed a design space to systematically design visualizations using our bank to generate a total of 128 candidate items, which were later reduced using the realism and diversity criteria. See our paper for more details about the reduction process. While preserving a similar distribution of items, our final design space contained 52 items, which were used in test tryout. We tried out our bank on 497 participants from Prolific and also asked open-ended questions to better understand their reasonings. Each participant got the same CALVI format, which is realistically how people might encounter potentially misleading visualizations, which are often mixed in with well-formed ones, making it harder to discern the misleading ones. So each participant received a set of 30 items that is composed of 15 trick items randomly sampled from the bank of 52, and a fixed set of 15 normal items without misleaders. So let's take a look at some examples. Here's an example with a chart and asks, what is the trend of the total number of apples harvested in farm X from January 11th to January 14th? Well, for this period of time, the visual trend seems to be first increasing and then decreasing. But the y-axis on the chart is also inverted, flipping the trends entirely. So the correct answer is decreasing, then increasing. But if someone did not notice the inverted y-axis, then just by the visual trends, they might pick increasing, then decreasing instead. And we call this a wrong due to misleader answer, and the misleader for this trick item is manipulation of scales, unconventional scale directions. Now, given this map, which region had the highest number of confirmed cases per 1,000 people? Well, the question asks for per 1,000 people, but the map isn't showing normalized numbers by population. It's just confirmed cases. So the correct answer for this one is cannot be inferred, but if someone only looked at the visual encoding and did not consider normalization, they might find the high absolute number of cases in region B and choose B instead, which is the wrong due to misleader option for this trick item with misleader missing normalization. After test tryout, we first revised our bank of 52 items using a method called item response theory or IRT analysis on test tryout data from 497 participants. There are different types of IRT models, and we use the 2-parameter IRT model to estimate the item easiness and item discrimination parameters for each item. We use these item parameters or how different questions separate participants of different abilities to revise our bank, and 2 items were removed as a result. We also revised based on qualitative analysis on the open-ended questions from test tryout. In the interest of time, I won't go into more details. You can find more information in our paper. We revised based on some validity checks as well, specifically a wrong due to misleader score, which is basically looking at whether people who answered incorrectly actually chose the wrong due to misleader answer. If the majority of people who got this item wrong were choosing the wrong due to misleader answer, then that's evidence that people who got this wrong have been misled. We also asked 5 domain experts to rate how relevant the items are for measuring visibility, and removed 4 items based on the validity checks. Overall, during test revision, we removed 7 items from a bank of 52, leaving 45 items in our final reliable bank. So CALVI is a bank of items that can be used to measure the critical thinking aspect of visualization literacy. We also want to note some important considerations for future research. Let's bring back some examples from before. In CALVI, there are types of questions that can be relatively straightforward to answer once the test taker notices the misleader, such as the inverted y-axis here. But there are also questions where attention is not enough to choose the correct answer, such as the missing normalization example, requiring test takers to reason more about the visualization construction process beyond merely looking at the visual encodings. Attention is not enough here because there are no direct manipulations or visual distortions. In addition, our design space and CALVI's bank offers a starting point for determining whether all misleaders are actually misleading. For instance, there are easier items like this one with an inverted color scale in the legend. The vast majority of participants got this correct, so this might not be misleading at all. This one, however, asks about whether there are any members of species C that weigh more than 5 pounds. This misleader seems to be a lot harder for people to reason about to arrive at a correct answer, suggesting that overplotting can be more misleading than others. The variety of items in CALVI's bank can help systematize the investigation of visualization misinformation. More broadly, CALVI also demonstrates the importance of extending beyond the core ability to read and extract information from visualizations and studying the different aspects of visualization literacy. Thank you, and read our paper for more details.